Welcome back, dear students of class 12. Today we will be discussing about cyanides and iso-cyanides. So cyanides are those compounds whose functional group is, say, C triple bond N, and this carbon will be attached to any alkyl group or the benzene ring. In case of iso-cyanides, the number of atom is carbon and nitrogen itself. But what you have to remember here is the bonding is from nitrogen atom to any alkyl group or any aryl group. So this is the difference between cyanides, here C triple bond N, and here it is the bonding is from nitrogen atom to, say, any carbon containing chain. Now, according to IUPAC, these cyanides are named as alkane nitride. According to IUPAC, these compounds are named as what? Alkane nitride. For example, suppose here this is the functional group, and here suppose you have one carbon here present here. That means CH2 group. This CN group is attached to CH2 group. So here the numbering starts from here, this cyanide group carbon. Please, many of the students they make a mistake in this. The carbon atom of the cyanide group has to be given number 1. Okay, so 1, 2. So there are how many carbons? 2 carbons. 2 carbons corresponding to alkane is what? Ethane. So it is ethane, and here, according to IUPAC, it has to be named as what? Nitride. So it will be ethane nitride. Please don't forget to consider this carbon atom of this C triple bond N. Okay, this is how it is named according to IUPAC. Had it been one more carbon over here, it would be 1, 2, 3. Then 3 carbons corresponding to alkane is what? It is propane. So propane nitride. Hope this is clear. Now, here in this case, suppose here also say CH3 group is attached. Okay? Now, first difference, as I told you, isocyanide, the bonding has to be from nitrogen atom. So here the bonding is from nitrogen atom to N. Here it is methyl group. Yes? Now, how is it named according to IUPAC then? It is named according to IUPAC by this particular general name. It is alkyl carbon amine. So here in this case, this is your functional group, okay, and this as a whole is named as carbylamine. Now here alkyl part, please look at it carefully. This alkyl part starts from the counting of carbon starts beyond this functional group. I mean to say, here the carbon atom is considered in numbering, but in case of isocyanide, it is not considered. It has to be from C. Because the bonding is not continuous here, means carbon chain is not continuous. For a naming purpose, for numbering purpose, carbon chain has to be continuous, but here it is carbon, in between comes nitrogen, therefore it is not considered. Your numbering starts from this carbon. So this is carbon number 1. So here you can say this particular compound contains 1 carbon. Therefore, 1 carbon, it has to be named as what? Alkyl. It's no alkane as in case of cyanide. It is alkyl. So CH3 group is what? Methyl. So methyl carbon. So the name of this IUPAC name of this compound is methyl carbon amine. Let's take another example. Say here you have CH3, CH2 and triple bond C. You can consider this bond. Here again this is your functional group, and you identify it as to be what? Isocyanide, because the bonding is from nitrogen. Carbon number 1, 2. So there are 2 carbon atoms in this chain. So 2 carbon atoms corresponding to alkyl is what? It is ethyl carbon amine. Okay, hope this is clear. Now let's move on to methods of preparation of cyanides and iso-cyanides. Now we are going to discuss about methods of preparation. First, we will be discussing about cyanide. Okay, so how can you prepare cyanide? So those are the here in your syllabus you have two methods of preparation. The number one is from we will be discussing for cyanides first. Okay, the first one is from alkyl halide, and these reactions are very simple reactions. Okay, please listen to it carefully. Alkyl halide can be represented as Rx. Now, whenever Rx is treated with alcoholic KOH, then what will happen? Whenever it is treated with alcoholic KOH, then elimination takes place. But since we have already discussed about such reactions, but here, since we are interested in which group? Cyanide group. Therefore, instead of this OH, what has to be present? Cyanide has to be present, that is KCN. Remember this KCN, okay? So whenever you treat alkyl halide with KCN, what will happen? Substitution reaction takes place. Here if you hit it, this cyanide will substitute this X. Okay? This X will go out, and in place of X, what has come? Cn. Now you will be getting R, C, triple bond, N plus KX. So this is how you prepare cyanides. Let's take one particular example. Say you have CS3, CS2, say chloride, and you are treating with say alcoholic KCN. Now what will happen? This Cn will substitute this Cl. So as it comes in, this Cl leaves, and you will be getting the product as CS3, CS2, C triple bond N plus byproduct is what? Byproduct is KCl. Okay? Now here in this case, in case of cyanide, you are treating with potassium cyanide, alcoholic potassium cyanide. Please remember this potassium. Okay? Now, if you take instead of alcoholic KCN, the reaction would be same, just one difference. In case of preparation of, say now iso-cyanide, this was one of the methods for the preparation of what? Cyanide. Now let's discuss in the same equation preparation of iso-cyanide. Iso-cyanide. Now instead of this KCl, if you take AgCl, silver cyanide, please remember this AgCl, you won't be getting this cyanide. If you replace potassium with silver, you would be getting iso-cyanide. Please remember this, okay? Whenever you replace K with Ag, now here it is what? Silver cyanide. You will be getting R and triple bond C. That means now this is what? This is iso-cyanide. Now this is what? The bonding is through what? Nitrogen towards this alkyl group. Therefore it is what? Iso-cyanide. So please remember this AgCl. If it is treated with AgCl, alkyl halide, if it is treated with AgCl, you would be getting isocyanide. Same alkyl halide, if it is treated with what? Alcoholic AgCl, you would be getting what? Isocyanide. Same alkyl halide, if you treat with what? Alcoholic KCl, as we did in our previous equation, you would be getting cyanide, not isocyanide. Please remember this. Now, the other method of preparation of cyanide is what? Again, methods of preparation. Second method for the preparation of now, again cyanide. It is a very simple reaction. It's a dehydration reaction. Whenever you treat amides, okay, with some dehydrating agent, say R, C, H2, C double bond O, NH2. This is amide. This is what? This is amide. Now, if you want to take a simpler form, just take R. Okay, let's discuss first the simplest version. This is amide. C double bond O, NH2 group is what? Amide group. This is amide. Now, whenever this amide is treated with some dehydrating agent like P2O5, phosphorus pentaoxide, or thionyl chloride, that is SOCl2. And if it is heated, dehydrating agent means what? Dehydrating agent means what? It will take out or it will eliminate water molecule. Here you have this two hydrogen and this oxygen will be eliminated as what? Water molecule. Now, there will be, since the valency of, once this is eliminated, the valency of nitrogen and carbon has to be maintained. Therefore, this double bond will be shifted between this carbon and this nitrogen. As a result, you will be having triple bond. Okay, please remember, this is an easy reaction. Here, dehydrating agent, you can use any one of them. Whenever amides are treated with dehydrating agent, then a molecule of water will be eliminated and you would be getting a compound where you would be having C triple bond N. And this is what? This is cyanide. And what is eliminated? Water molecule. Okay? So let's take one particular example. Say you have CH3, C double bond O, NH2. You are treating with say P2O5 and you are heating it. What will happen? This water molecule will be eliminated, and as a result, so let me write this product here. You would be getting CH3, C triple bond N plus water molecule. And this is what? This is 2 carbon, 1, 2 ethane nitride. Or this is ethane nitride. Okay? Please remember this. This is what? Ethane nitride. So we have discussed two methods of preparation for cyanides. For preparation of cyanides. We discussed one method for the preparation of isocyanide. Now, one more method of preparation is there, which we have already discussed for isocyanide in our previous video. That is carbylamine reaction. Okay? I hope you still remember that reaction, carbylamine reaction, where you had a characteristic, this offensive, unpleasant smell, because of which you detected what? First degree amine. So that is also one of the method for the preparation of isocyanide. So let's discuss that once again in brief. Method of preparation for isocyanide. Carbylamine reaction. Whenever you had first degree amine, like say R NH2, first degree amine, whenever you are treated with chloroform CaCO3 and alcoholic KOH, what did you observe? You observed an unpleasant smelling compound being formed. And what was that? That was R and triple bond C. This is isocyanide. And what were the byproducts? The byproducts were water molecule and KCl. So if you want to balance this equation, 3Cl, so 3 potassium, 3 OH. Now this equation is balanced. This is the second method of preparation of what? Isocyanide. And this reaction is known as what? Carbylamine reaction. Carbylamine reaction. And moreover, we were familiar with this carbylamine reaction whenever we were discussing about test to distinguish between first degree, second degree and tertiary amine. This test distinguished first degree amine from second degree and third degree. This reaction is given by only first degree amine. Okay? And that we had discussed. And here, same reaction is also used as a method of preparation for isocyanide. Okay, so these many things are there in your syllabus regarding cyanides and isocyanides. And in our previous video, we have discussed about all these topics well under compounds containing nitrogen, and one more topic is left, that is diazonium salts, which we will be discussing in our next videos. Till then, keep practicing all these reactions. Take care. Bye.